Hello everybody. We're going to continue the rest of this practice midterm. A couple of days ago, we went through a couple of these questions. We went through number 1 and number 2. So here I'm going to load up the practice midterm again. There are unlimited attempts, so you should be able to open this up. Okay, so yeah, a couple of days ago, we went through question 1 and question 2. Feel free to take a look at the previous recording for that. Let's see, let me load up my notebook. Here it is, practice midterm. And then I need to run this first cell again. Okay, there it is. We left off on the next 3 questions. I wanted folks to try it out themselves before getting exposed to possible solutions. So yeah, there's really just a couple more questions. 3, number 4, number 5, and then finally number 6. And that's about it. We left off at some sample test cases. Like over here, we did question 1, number 2, and then number 3 right here. I left it blank, hoping that folks would kind of try it out themselves. In particular, I left some test cases here. I should have documented this a little better. But this is like a local testing cell. All right, so assuming we already defined this function, this should evaluate to false. All right, this is like a test case. Should evaluate to false, meaning if we print it, it should print false. All right, so you can read these directions later. It's pretty much saying, hey, is the area of a triangle less than 10 or greater than 10? That's pretty much what it's asking for. Okay, and just to make some more sample test cases, if I were to call it with different arguments, like let's say I were to have a triangle with a really large base and a really large height, right? Like let's say 50 as a base, and then let's say like 80 as a height. It doesn't really matter. The point is, if the base is 50 and the 80 is the height, then our triangle area is for sure greater than 10. Right, meaning that this should evaluate to true. All right, because it is greater than 10. So I'm gonna go ahead and print this out as well. All right, this is pretty much where we left off at, just kind of giving some sample test cases. So yeah, let's go ahead and do some possible solutions to these functions. All right, hopefully folks gave it a try. This way you can run into errors along the way. Okay. So first things first, you'd want to add this tag. So I'll copy this and paste it over here. All right, once again, the reason is because we have randomly generated exams. So this tag lets the feedback grader understand what function to grade. Oh, hold up, I made a mistake. I just realized this error right here. I meant to call it limit. Okay, anyways, let's go ahead and write this function. All right, so the bare minimal requirements for writing a function is to at least get the name right and have the parameters, right, the arguments. So let's go ahead and get that. Right, so the bare minimal is define a function, right, called triangle limit, and it needs to take the correct arguments. Right, in this case, this function is asking for a base and a height. There it is. And then I guess you could put in a docstring as well, right? This is also kind of bare minimum. This docstring will help you understand the problem. And so what is the purpose of this function? Right. Well, you can pretty much read the question here, right? The purpose of this function is to determine whether or not a triangle's area exceeds 10. Exceeds 10, right? That's really what it's asking for. Now we gotta describe as inputs and outputs. Right? As for the inputs, there are 2 arguments. There's the base and the height. Right? So I'm gonna go ahead and describe them. This is a number, right? In particular, a float or a decimal, right? A float is another way of saying decimal. So it's a float that represents the size of the triangle's base. And then this one is the same thing, right? It's a float that represents the size of the triangle's height. Okay, and then finally we are expected to return some sort of Boolean value. So this returns a Boolean. That's pretty much it. So we're describing inputs and outputs. Okay, so let's go ahead and get this ready. All right, it might be a good practice to kind of test frequently, meaning that maybe you should build a skeleton first and then test it. Right, so meaning this will help you catch errors earlier on. So for now, I'm actually going to hard code a dummy return value. Right, I'm going to hard code it to always return false. Right, this is kind of like a starting point. Right, meaning that no matter what we give to the function, it's going to say false. Right, so I'm going to go ahead and test it. The reason why is so I can catch errors earlier on. So let me go here, and hopefully there's no syntax errors. So I'll play this cell, meaning it's going to invoke this function. So let me play it. Okay, cool. It printed false, false. That's exactly what we expected. We did not get any syntax errors, so it's probably a good idea to move on. Okay, so yeah, we just need to find a way, right? This function needs to calculate area, right? It needs to calculate area, and then based off that area, you got to return some sort of Boolean. So yeah, first things first is you should probably, calculate the area, right? Area is equal to something. Right? You can call this variable anything you want. I'm just gonna call it area. And then if you're not sure what the formula is, this is an open book exam, open internet. So you can Google this stuff, right? You can Google up area of triangle. All right, so area of triangle. Oh, it tells right here. Okay. I'm gonna look at images. Okay, yeah, this is kind of a good one. Area of a triangle takes two inputs, right? Two parameters. It's got a base and a height, right? So it's 1/2 base times height. So you could go ahead and represent this in however you want. Right? One way is you can just say 0.5 times base times height, right? So yeah, there it is. We calculated the area, and now we need to kind of branch off into different scenarios, right? Like basically, if the area is greater than or equal to 10, then we're going to return true, right? Otherwise, false. So you can do this in if statements. I'm not sure if the feedback grader might like that. So here's what I mean, right? You can pretty much make a branch off of it. I haven't really covered branches and if statements yet. So one way you could do this is by saying, oh, if area is greater than or equal to 10, then return true, right? And then else return false. Right, this is definitely one way. We haven't really covered this yet. But let's see what happens. Right, let's see. So let me press play and then locally test it. Right, hopefully we get the right stuff. Okay, cool. So it prints out false and then finally prints out true. Right, which makes sense, right? Because this is too small of a triangle and this is a really big triangle. Okay, I did want to point out that this is a valid solution. I'm not sure if the robot likes it. Let me find out. It's gonna take like 10 seconds. So let me press play here. So this is remote testing, right? If you were here last class, this is uploading your code to a server, and then the server is kind of grading it. So there's quite a bit of overhead. Oh, okay, so in this case it says the solution uses forbidden syntax. It's pretty much saying that we use concepts that we haven't learned in class yet. We haven't really learned if and else statements in here. So on a case-by-case basis, I would probably accept it, right? The feedback grader kind of, in my opinion, lowers creativity a bit by forcing you to do something in a certain way. But yeah, I mean, if you wanted to use syntax that we've already covered, right, you can actually combine this into one line. Right, so it's pretty cool. Right? How do you combine this into one line? Right, basically, you just have to return something. Right, return true or false. Right, so you can put a Boolean expression in here, meaning it's a expression that evaluates to either true or false. So you can literally just say return area is greater than or equal to 10. Right? This is a Boolean expression. So I'm going to put parentheses around it. You don't need parentheses, but it makes it a little easier to read. So yeah, what I just highlighted, this evaluates to either true or false, right? Depending on what the area is, right? So yeah, that's true or false. So let's go ahead and play and then test it again, test it locally. There it is. I got the same exact results. And then let's ask the remote grader. Okay, great. All tests pass. Cool. So we're good. Once you're confident that you're good, you can copy this into the canvas. All right, so go ahead and copy and then paste into here. I do recommend formatting it. So select everything and then pre-formatting it. I'm just gonna make the font a little nicer. Okay, cool. So there it is. Let's move on to the next question. All right, a couple more. Okay, they get a little harder in difficulty. Okay, question 4. Let's see. This one looks like it's also dealing with a triangle. The actual midterm is gonna have more diverse questions. Everyone's gonna have a randomly generated exam. This practice one just happens to have a lot of triangle stuff. But yeah, this one is saying, hey, write a function called hypotenuse, takes 2 arguments a and b, and then it returns the hypotenuse. Right? If that doesn't mean anything, you can Google this stuff up. I already pulled this up last class. Right, a hypotenuse is like the side of a triangle. It's like the diagonal side of a right triangle. So you can look up the hypotenuse formula. And yeah, I pulled this up last class. Right, hypotenuse is c, right, which is equal to some equation. Right? You don't really have to know math for this class, but yeah, this is really the Pythagorean theorem. Okay, so let's go ahead and implement this. Okay, so we need to have a function called hypotenuse. Oh, I forgot to get the tag. So let me copy and paste this tag. Copy, paste, there we go. Let's go ahead and define a function called hypotenuse. All right, bare minimum syntax we need is to at least have the name. All right, we got the name. Now we just need the inputs. This function is expecting 2 inputs. So let me go put 2 inputs here, A and B. And then also the docstring. So the docstring here, the purpose of this function is calculates the hypotenuse given the other 2 sides. Calculates the hypotenuse of a right triangle. Right, right triangle just means it's got a 90 degrees. Okay, let me describe its inputs and outputs. So the inputs, there are 2 parameters. One is A and one is B. These are both the same, right? This is a float. This is another float. And then let's go ahead and describe its outputs as well. The output is it's going to return something. We see it here. It returns the hypotenuse. All right, that's pretty much it. So let me, it's good practice to, once again, frequently test. So I'm gonna return a dummy value. Right, I'm just gonna return 0 for now. 0.0, it doesn't matter. The whole point is just so we can see there's no syntax errors. Okay, so let me play this cell. There it is, I loaded the function in, and let's go ahead and test it. All right, it should evaluate to 0. There it is, yeah. So both cases evaluated 0, which makes sense. But yeah, we didn't get any syntax errors, so that's good. It's totally possible to get syntax errors, right? Like if you were to kind of miss an indent or misspell something, then the local testing cell would kind of catch it. All right, like for example here, let me make a syntax error. So I'm just gonna go in the function and type in like some garbage, right, and then maybe some more garbage. Okay, let me press play to see if it catches it. Okay, cool. So I press play on this cell. There's no errors. there's none. That's because we never ran the function. So if we were to go down here and run it, right? So run it. Oh, there we go. We got some syntax errors or name errors, right? It says, oh, a name is not defined. So yeah, that's pretty much why I'm kind of testing frequently, right? In this case, I return 0, so I can have a minimally functioning. Okay, if anything, all we need to do now is kind of, let's see, calculate the hypotenuse, right? So you can go ahead and use this formula. There's multiple ways you can implement this. I'll show a couple of ways, right? One way I saw a person do in class earlier. They said, oh, c is equal to the square root of this. So yeah, some people would put it's a something square root, right? The square root of something. So one way you can represent the square root is by saying it's to the half power. Right? This is just one way. Right? If you come from like some sort of algebra class, you know, raising something to the half power is the same thing as taking the square root. And these two asterisks is the power operator, right? If you're curious, you can look up power operator Python. All right, so the power operator I can't seem to find the primary documentation here, but it looks like the search assist here got it right. Right, the power operator is 2 asterisks. Okay, cool. So yeah, it's just something, the square root of something. That's what this is saying. So you could go ahead and say, you know, a squared plus b squared. All right, that is legit. Right, the order of operations says do the inside first, and then take the square root of it. So let's go ahead and try that. I'll go ahead and return c here. Okay, and let's test it. So I'll load the function in, and then let's test it. So I'm gonna, hopefully it evaluates the right numbers. So let me press play. Sweet, it looks like it's evaluating correctly. All right, 7.81, 19.20. Yeah, it looks good. Right, this is just one way. If you know, another way you could do it is, you know, import the math library too. You don't really have to, but if you did a bit of Googling, you might have seen that a way of doing this is you can say math.square root. Oh, I need to import math for this because this is from a library. So at the top of here, I'm going to import something called math, which will let us use some functions like a math.square root of a squared plus b squared, right? A squared and b squared. All right, so yeah, these two lines are equivalent. I'm gonna stick with the first one, the second one I mean. Okay, let me test it. And oh, it looks like I got something wrong. So it looks like, so it says math.square root takes exactly 1 argument. Hopefully people might see what I did wrong here. I did a really small typo. So it takes 1 argument, and I gave 2. Pretty much I meant to put a plus sign instead of a comma. That's what I meant to put. Square root of the sum of these squares. That's what I meant. Okay, so press play, and there we go. All right, we get the correct numbers now. All right, if you want to go a little more overkill, right, there is an infinite way that you can do something in Python. You can also represent it as saying, oh, the power. All right, let me actually look at the math library in Python. Let me see, there's a power function. Okay, there is a power function. Looking at their primary documentation, This is pretty much the doc string. So it takes 2 arguments, x and y. Okay, cool. Let's go ahead and use it. Yeah, so another way you can represent this is by saying math.pal something plus math.pal something. Okay, and in this case, pal is a squared, and then this one is b squared. Right, I'm pretty much going based off the documentation. It's saying that math.pal returns x to the power of y. So that's pretty much what I'm using here. Okay, let me go ahead and test it. So boom, and then boom, there it is. All right, same thing. Okay, cool. So we've done a lot of local testing. Let me go ahead and ask for feedback. Okay. Yeah, as you'll see in programming, there are so many different ways of doing something. Cool, all tests pass. Great. Okay, let's move on to the next ones. Wait, hold up. Any questions so far? Okay. Cool, cool. Let's see, let's move on then. If folks are kind of curious, this is kind of off topic right here, but we pretty much programmed calculators. I know people might be getting tired of programming calculators. If you've ever had a calculator called the TI-84, we're kind of programming that. So here's what I'm talking about, TI-84 or TI-83. Right? It just depends on what generation you're in. I think people use TI-84s now, or maybe some other variant. But yeah, if you ever had one of these in like a math class, there's a program button on it, and it pretty much lets you program functions, right? Meaning that you could, if you know Python inputs and outputs, you can kind of generalize this to programming a calculator, right? So you can pretty much, if you're in an algebra class or geometry class, you can kind of speed up the workflow, right? You just program some sort of function that takes inputs and then produces some sort of output. So it's some pretty cool stuff. That's one way you can think of what we're doing. Okay, let's go ahead and move on. Okay, where are we at? Question 5. Okay, second to last one. They do get a little harder. Okay, question 5. Hopefully you've read it by now. If not, go ahead and pause the video and try to understand it. Yeah, this question is really asking if you know if you can find a way to swap elements in a list. That's pretty much what it's asking for. So, before we code anything, let's kind of go over the high-level overview on what it means to swap elements. So I'm actually going to load a sample notebook. I'm just going to load a new notebook here. I'll name it, I'm just going to name Untitled. So this is kind of like a playground notebook. All right, let's kind of understand what it means to swap items. So, say I had a list. Right, don't worry about this question right here. Right, just pretend we had a list called to-dos. All right, so I'm gonna hard code it to have some string data. All right, so I'm gonna hard code it to have like 4 string elements. I'm just gonna put something like wake up, brush teeth, eat breakfast, and then program. This is actually like the life of me in the morning. Okay, so let's see. Eat. Okay, so let me test it. Okay, cool. So if I were to print it here, right, to-dos, it's just gonna echo it out. All right, can folks think of a way on swapping elements? All right, like without redefining this whole list, how do we swap certain elements? Like let's say we wanted to do something in between where the middle elements are swapped, right? In particular, we want to swap element 1 with element 2, right? Because once again, lists start counting from 0, right? 0, 1, 2, 3. What do we do if we want to swap the 1th element and the 2th element? How do we do that? Right? Without, I mean, I know you can just hard code it right here, right? You can literally just put eat breakfast, right, and then brush teeth, right? You can do this, but it's not really solving the actual problem. So let me undo this. Right, the actual problem is given some sort of list, right? It could be any list. How do you swap 2 different elements? Actually, yeah, let's go ahead and think about that, right? Think about it for a second. How do you swap? How do you swap these 2 elements? Okay, hopefully people maybe thought about it. Right, we want to do something in between. Right, maybe let me clear out this output real quick. Clear output. Maybe you wanted to say, oh, set this element equal to the next one, right? You could totally do that, right? You could totally say, oh, to do's 1 is equal to do's 2. Right? People see what this is saying. It's saying set the left element equal to the right one. Right? So this is saying grab the 2th element and then put it at the 1th element. Right? So it's gonna grab this and move it over here. Right? It's kind of like swapping. Right? You see what I mean? So let me play it and see what happens. Okay, does this kind of make sense right here? We initialize our list with here, and then this is a reassigning, right? It reassigned the 1th element. Yeah, so we got half the swap done, but how do we do the other swap, right? Because we have to get the brush teeth into the other side, right? Yeah, you have to think about it. Hopefully people kind of see that our approach here is a little flawed. Right, the approach here is we lost data. Right, what data do we lose? We lost this data right here, right? The element that got overwritten, right? It got overwritten. We lost that data, meaning that if we were to do the other side of the swap, right, nothing is gonna happen, right? Like if I said to do's equals to do's 1, right? You see how it looks like it's swapping, but it's not, right? See, it's not. It's because our first line lost data. Right? Our first element, I mean not first, the 1th element got overwritten. So yeah, hopefully people see the flaw in this approach. Right? The flaw is we lost data. So one way you can counteract this is by doing something called a temporary variable. A temporary variable aims to save the data before it gets overwritten. In this case, we need to save the 1th data, right? Because that gets overwritten first. So you could do a temporary variable and set it equal to do's. Right? You can call it whatever. I'll call it temp. I'll set it equal to do's 1. Right? Meaning it kind of makes a copy. Right? So it's storing the variable before it gets overwritten. Right, and then next is to do's 1 is equal to do's 2. Yeah, this makes sense. But then here, this is the part where we need to put the data that we stored into the next one. Right, so this would be temp. All right, people see what's happening here. So if I press play, and we see that it finally swaps the 2 elements. All right, people cool with this so far? Yeah, so that's pretty much what the question is asking for. We're not really done with the question yet. We are in the playground cell just to kind of play around with lists. And in particular, this is hard-coded. This is hard-coded because we have data here that's put into the source, and we also hard-coded these indexes. Right? We hard-coded 1 and 2. Right? But the function is going to ask for a more general version of this. So here, let's go to the function now and try to finish it. Okay, so question 5, here we are. Let's go ahead and insert the tag. Copy and then paste. Great, there it is. Question 5. Okay, so define a function called list swap. It's gonna take 2 arguments. Okay, it is a little hard to read right here, but the 2 arguments here are supposed to be L and I. So L and then I. I know it's a little hard to read because they kind of look alike. It kind of reminds me of license plates that have like L1, L1, L1. Has anyone seen that before? I've actually seen this before. I've seen someone with the license plate L1, L1. Oh, it doesn't show up properly here. L1, L1. Yeah, it looks something like this. But since the font I have, it kind of makes them look a little different. Yeah, that's kind of what it reminds me of. Okay, cool. So there we go. We have 2 arguments, and let's go ahead and describe what the function does. So the purpose of this, swap 2 elements in the list, right? But it's going to be a general, meaning that we're not going to hard code the index nor the values, right? The index will be specified by this I, and then the values will be specified in the L. So let me go ahead and describe the arguments. The list to, how can I describe the list to work on? Yeah, list to work on. And then I, the index, the position. It's the position to swap. Right? Technically, there are 2 positions. This question is asking that the position is at I, and then the next one over. Okay, so let me go ahead and describe its output. So this is going to return another list, right? It's going to return the list that has the swapped elements. Okay, cool. Hopefully people understand the purpose of this so far. If not, you can go ahead and take a look at this local testing cell that we did a couple days ago. And so I would probably maybe rewind to the past if you haven't seen this. But yeah, people see what this is. This is data that gets sent into the function, and then the function will need to work on it. Right, so yeah, go ahead and read this later. Let's go ahead and apply this. This is from the other notebook that I opened up. All right, let's go ahead and apply this swapping method. So we are working on the L right here, right? L represents the list. So, you know, before we start swapping, it might be a good idea to store the temporary variable. All right, so what did we do earlier? We stored the temporary variable that was going to be overwritten. All right, so it's going to be L of I. All right, that's what's happening over here, right? So L of I, we're storing it, and then we can overwrite it. So we can say L of I is now equal to the element that's next to it, or I plus 1. And then finally we can do the other reverse swap, right? Which is saying that the right one becomes whatever we stored from the left one, which is temp. All right, so there we go, and then go ahead and return the list, return L, and let's see what it evaluates to. So I'll press play here, and then hopefully these are right. Okay, so the first one should evaluate to that. Second one should evaluate to that. Cool, looks good. All right, people cool with this so far? Pretty chill, right? Let me go ahead and ask for feedback. So I'll send it to the server for remote testing. Okay, cool. All tests passed. Great. We just swapped two elements in the list in a general fashion. This might seem like it might not have a lot of uses. It does have a lot of uses though. Like, before I talk about the use cases, let me show other ways you can do this. There's so many ways you can do this. You can just Google stuff too, right? Like maybe during the exam, you could Google up like, oh, how to swap list elements in Python, right? This would be a really good search. And I would not really look at the AI stuff because, sometimes it could be wrong. In this case, it's actually right. In this case, it's actually right. But let me look at Geek for Geeks because AI is sometimes wrong, especially when it comes to harder questions. But it's better to not really have AI do the work for you because it's gonna ruin your creativity. So yeah, I just looked up how to swap two elements in a list. Right, here's one way. This is a Python program that swaps two elements. It's swapping the first element with the last one. Right, this is not what we did. We did this way right here. Right, this way is using a temporary variable. Right, this earlier one, it's actually doing the same thing, but it looks cleaner. I would probably prefer using the temporary variable one just because this syntax it works in a lot of languages. Right? This is kind of how it works anyways. Like these up here, right? This is a Python way. It's really doing the same thing as here, right? It's the same operations, but it just looks cleaner. But I would prefer this because a lot of other languages support this syntax. Yeah, in other languages, this is not really valid. In particular, the left side of the equal sign can't really have multiple things. Right? If you're coming from like C or C++, you can't really put multiple things on the left side. But in other languages or C++, you can put one thing on the left. Okay, hope that kind of makes sense, right? I'm basically saying this approach is more general, right? It's the operations, the actual operations that swap elements. Okay, cool. Sorry for going on a bunch of tangents. I do have one more tangent to go on though. Pretty much it's about the importance of swapping things. People might be wondering, oh, what's the point of swapping things? I mean, one use case is sorting algorithms. So a very frequent problem in programming is to sort things. Sorting means to kind of swap things over and over again. So over here, this is a visualization of certain sorting algorithms. Right, you can kind of imagine this as a list. So imagine I created a list of 10 items. Right, so yeah, imagine this is the list of 10 items, and maybe you want to sort them in ascending order. So you can think of it as like a deck of cards. You can think of it as a bookshelf, right? Because some bookshelves need to be sorted in ABC order. Right, how would you plan on sorting this? Well, one way is to swap things over and over again until they're in correct order, right? Hold up, what's wrong with my microphone? Give me 1 second. Okay. Anyways, I was asking, how do you sort this? Well, there's lots of ways you can sort it. Right. If you were to kind of sort it like a deck of cards, this is called selection sort. Right. Selection sort means to kind of. Oh no, I'm gonna go to bubble sort first. Actually, bubble sort means to swap things over and over again until they are, in the right order. So this is bubble sort. It's not really part of the class, but you'll see what I mean. All right, so if there's two adjacent elements that are out of order, it's gonna swap them. See what's happening? All right, if the elements are out of order, swap them. And do that over and over again. And then at some point, it's going to be in sorted order. So let me fast forward it. There it is. All right, let me just play it one more time. So let me sort another one and do it again. There it is. All right, sort it. Right, this is actually a pretty inefficient algorithm, right? Bubble sort. It's a pretty expensive computation. But yeah, hopefully people are kind of seeing the use cases of swapping items. Okay, cool. Let's move on to the last question. Okay, write a function called nameTag that pretty much takes two arguments and spits them back out. So let's get that started. So define a. Whoa, hold up. Let me get this tag first. Get this tag. Okay, let's define the function called nameTag. It takes two arguments, two strings. And then let me describe the function. The purpose of this is really to print the arguments back out. That's really what it is. In particular, it's going to print a greeting. Right, so this syntax down here, the for example, it's saying that when we invoke the function, it should print this out. Right, it shouldn't really return it. I know folks might be tempted to make a return statement to return a string, but this function doesn't really specify to return anything. So you can pretty much assume that it's just going to print, right, not return it. Okay, so the two arguments here is two strings. I'm just going to keep it short. The last name is a string. All right, it's pretty much first name, last name. There's no returns because the problem never asked for it. All it needs to do is spit out the functions, spit out the inputs, I mean. So you can pretty much do this in a print statement, right? A print statement that pretty much interpolates these variables into it. There's so many different ways you can do it. I do prefer the F string because you can just say, hello, my name is something, comma something. Right, that's pretty much what it is. And then here, just first and last. Or actually last and first. There we go. Let's go ahead and test it. So I just loaded the function into the kernel. Let me go ahead and test it. So press play, and let's test it. Andrew Tack. Oh, actually, I got this wrong. Can people predict what's going to happen if I press play on this? Yeah, try to predict what's going to happen if I press play right now. Okay, maybe you thought that I got the arguments wrong. So let's see. I press play and it says, yeah, name tag is missing one positional argument, last. Right, so it's saying I'm missing an argument. I only gave it one input or one argument. right? This is a single string. So it technically went into the first, and then the function didn't know what the last is. So you got to split this up. So I'll split it up by commas right here, and that should get rid of the error. There it is, right? Name tag. Hello, my name is Tack Andrew. Let me test it again with different names. Let me say, what's another random name? I don't know, I'll just put Michael Jackson. Okay, you don't really have to print this because the function already prints it for you. There we go. Right, just testing it. So let's ask for remote feedback. It's probably good. Okay, I'm pretty sure it's good. I'm just gonna not wait for this and go ahead and copy this over. So copy and paste into Canvas, and then pre-format it. There we go. This way you don't lose your data. Cool, so that's it for the exam. All right, once again, when you're done with the exam, go ahead and upload it on the last question. Yeah, I already went over this on the last recording. Okay, so yeah, that's pretty much what the midterm looks like. The actual midterm will have more content on it. You know, this is really here to practice the format. You should probably be familiar with, let me pull it up here. Yeah, honestly, I don't mean to be too vague, but you should probably be familiar with everything before lesson 10. In particular, make sure you're cool with navigating lists and dictionaries. That's a big takeaway in here. And then maybe writing a bit of HTML strings. Okay, cool. Hope that makes sense for everybody. Any questions? All right. Well, thank you all for being here, and good luck on the exam if you need it. Hopefully you don't need it. It shouldn't be luck-based. Okay. Good night.